Hi everyone, my name's David Riesfeld and I'm a Customer Engineering Manager at Google Cloud. Today we'll be discussing Media CDN's logging and monitoring capabilities to help you understand how to gain deeper insight into monitoring performance and ensuring a smooth experience for your end users. Let's get started. Logging and monitoring are an essential part of any service. Both are critical for troubleshooting issues, analyzing performance, and site security. If there's ever an issue, the first place you'll likely turn to are your logs and dashboards. They can help you quickly understand what's happening and the impact on your systems and users. Media CDN is tightly integrated with cloud logging, which means you get real-time visibility into Media CDN's performance and behavior. You can see trends as they're happening, not hours later. For simplicity, Media CDN logs are automatically ingested into cloud logging with a 30-day retention period. There's no extra configuration needed. Do you need to keep logs longer? No problem. You can easily export them into BigQuery or cloud storage. If you need to send the logs to an external system, you can even stream them to a pub sub-channel. Cloud logging also has powerful filtering capabilities that allow you to answer CDN-specific questions. You can narrow down your search to find exactly what you need. For example, you can quickly find out, was this response served from cache or from the origin? Which requests are taking longest? Cloud logging gives you the power to answer these questions and more with an easy-to-use query syntax. So what kind of data can you expect to see in Media CDN's logs? We can break down the data into 4 general categories. First is HTTP data. This section goes into the core details of the HTTP request itself. You'll see the protocol used, the request method, the URL path, as well as the status code to understand if the response was successful or not. Next is CDN data. This is where we can understand how Media CDN handled the request. You'll be able to quickly see if the response was served from cache or if it needed to be fetched from the origin. You can also gather information like location of the node that served the request, which can be helpful to troubleshoot any issue should they arise. With client data, we shift the focus to information surrounding the client that made the request. By default, Media CDN will include the client's IP address, user agent, geolocation, and the end user network. In addition to geographic data, you can also understand what the experience was like for the end user by viewing helpful performance metrics like time to first byte, time to last byte. And with native support for Common Media Client Data, or CMCD, you can gain insights into the quality and performance the end user is experiencing while streaming. And finally, we have security data. By default, you'll be able to see details about the TLS connection, such as the version number and the SNI hostname used for the request. If you're leveraging Cloud Armor to protect your workload, which is Google's web application firewall and DDoS mitigation service, you'll be able to see which rules triggered, why they triggered, and what action was taken as a result. While logs provide incredibly detailed information about individual requests, dashboards give you a high-level view of your web application's performance. Dashboards offer visualization and aggregated metrics that make it easy to spot trends, identify potential issues, and track the overall health of your service. And the good news is, Media CDN integrates seamlessly with cloud monitoring. With 25 pre-configured visualizations available alongside a pre-built monitoring dashboard, you'll gain instant insight into key metrics such as cache hit ratio, latency, stream quality, and bandwidth consumption. No need to start from scratch. Now let's head on over to the console and take a look. In this demo, we'll be spending most of our time in the Log Explorer reviewing Media CDN logs. Log Explorer is part of Google Cloud's global logging system, which is responsible for capturing the logs of nearly every service Google Cloud offers. This allows us to take advantage of all the features native to cloud logging, such as real-time logging and robust data querying. Aside from enabling logging when creating or editing your Media CDN service, there's nothing else that needs to be done to send Media CDN logs to cloud logging. The plumbing is already configured behind the scenes, so we can start looking at logs as soon as the first requests are sent. Logs that are generated anywhere around the world will typically show up in Log Explorer in under 2 minutes, but usually much faster than that. The logs themselves are JSON-based and are fixed in nature. If any custom logging is required, I'd recommend checking out our service extension solution that can help with that. Let's dive in and take a look around. The first thing I typically do when reviewing logs is to filter specifically for the service I'm interested in. On my screen, we see a nice clean view as this tenant was created specifically for this training. But in the real world, there can be many more services funneling their logs into cloud logging. It can be quite busy. To filter for Media CDN logs specifically, let's click on Edge Cache Route Rules in the log field pane on the left. You'll notice that the query was added automatically into the query input box. And if we click on the log field or values, you'll see additional queries being added, which allows us to be quite prescriptive in what we want to see. The next thing we want to do is make sure that the correct time frame is selected in our time picker at the top. I'll leave it set to the last 1 hour for now. Before we dig into the logs, it's worth mentioning how useful the log field pane can be to understand distributions of your log data. For example, I can quickly see how many logs match the video segment path **.ts. If this pattern looks familiar, we covered it in our host and route rule video. So be sure to check that one out. So right from the start, we can begin to gather useful information quickly if we were performing an analysis or troubleshooting an issue. Moving on, in the middle of the page, we can see all of the logs that have been generated in the last 1 hour. Let's go ahead and crack open a log line and see what's inside. At the top of the log line, let's click on Expand Nested Fields so we can see all of the data captured in each JSON stanza. At the top, we see the HTTP request stanza, which contains the HTTP data, such as the protocol used, the referrer value, the remote IP, which is the connecting IP to Media CDN, the requested URL, and other useful information like the status code, user agent, and the size of the request and response. Under HTTP request, we see the JSON payload stanza, which shows us data that is more CDN specific in nature. Here we'll see log field data like cache ID, which shows us all of the Media CDN nodes and locations that served the request, cache mode, which tells us which cache mode was configured at the time of the request, the cache status, which shows us whether or not the object was served from Media CDN's cache or not. Let's take a minute to focus on this field to understand what we're seeing. If we see that the field contains all uncacheable values, that tells us the object was not eligible for cache and that it was fetched from the origin. If we see miss, that means content was eligible to be cached, but wasn't found in the cache at that point in time, so the object was fetched from the origin. And if we see a hit anywhere in the cache status field, that means that the object was served out of Media CDN's cache machine. Now that we understand the cache status field, let's continue. You'll also see fields like Metra IATA code, which shows us the general location using an airport code where the object exited Google's network on its way to the client. And also the proxy status field, which is an IETF standard field. Moving down, we can quickly see which origin was selected to serve the response, as well as the origin's IP address. This can help with troubleshooting content or routing issues. There is also helpful performance-related data such as time to first byte and latency, which is considered time to last byte in this context. Taken together, this can help you uncover any performance issues or bottlenecks. You may have noticed there is an enforced security policy stanza as well. This is related to Cloud Armor and will be present in every log line if a Cloud Armor security policy is not configured. If it were configured, we'd be able to see which Cloud Armor rule was triggered and what action was taken, whether it was a block, allow, or the request was rate limited. In addition to HTTP and CDN data, we can also see data about the client that is added to the logs automatically, such as the client ASN, city, and region that the IP address originated from. This can help us filter logs that were generated in a certain region so we can narrow down our analysis. If we scroll down a bit further, we will also see Resource Stanza. This is where we can gather information about which Media CDN service this log is related to, the rule that was applied based on the matched path, as well as the origin that was selected. This helps paint the full picture of the request and response flow, because now we know what the request URL path was from the HTTP request stanza, we know which Media CDN rule was applied, and we also know which origin served the request. With that information, we have lots we can look into. A stanza that I have not mentioned yet, but you may have noticed, is the CMCD, or Common Media Client data. CMCD is a standard way for media players to share information with CDNs about their playback behavior. It's one way the customers can understand what the playback experience is for their users on the client side. Media CDN supports CMCD data natively that is transmitted through the HTTP request headers or query string parameters. Since my media player is adding CMCD data as an appended query string to the original request URL, we'll see that reflected in the logs here. And finally, let's see how we can use Media CDN's HTTP headers to find a particular log line. Let's switch over to our video player page for a moment and take a look at one of the responses. Within the HTTP response, there is a header that's automatically added called xRequestID. This is a unique identifier that we can use within Log Explorer to find the log line associated with this response. Let's copy that and click back over to Log Explorer. Within the query input box, let's remove the existing query and paste in our request ID, and then we'll click Run Query at the top right corner. As we can see in the main panel, we have one log line that is displayed. Let's go ahead and expand that, and we'll see that our request ID is highlighted, confirming the logs we are looking at were generated by the HTTP response we just observed. Something like this can help if you are testing new logic or troubleshooting unexpected behavior, so it's a good tool to keep in your tool bag. And that's it. In this video, we walked through the benefits of leveraging Log Explorer for log analysis and troubleshooting the Media CDN service. We reviewed many log lines and learned what their purpose is, and we also learned how to use a request ID to look up specific logs in the event that we need to filter for a specific HTTP request. Well, that's all I have for you today. Thanks for watching, and I'll see you on the next one.